Welcome to the pre-calculus skill video number 5. I can solve and graph linear equations and inequalities in 1 and 2 variables. Alright, the trivia question for this video is, below is a map of something famous about some city. Name what the map is of and what is the city. Alright, we'll start our notes on page 5A. And our first page we're going to be talking about linear equations and inequalities with one variable. And truthfully, this is very old school stuff that we've been doing since Algebra 1, where what we have is an equation with just one variable. It's not raised to any degree, and you are simply solving for the variable. So in the first step, I subtracted 7 from both sides, and then I divided both sides by 3. So it was a two-step process. If we were to graph it, we would be graphing a number line and then placing just a singular dot right where the number is. I've provided a second example, and in this example the difference is we have a variable on both sides. So I rewrote the problem and the process of solving. In the first step I distributed the 2 in. In the second step, I moved all x terms to one side and all constant terms to the other side. And in the third step, I divided both sides by 12. So this was a 3-step process. And the solution, again, is a number line with a singular point. Okay, let's take a look at some linear inequalities. This process is very much the same. The only difference is the equal sign has been replaced with an inequality, and for those forgetting, an inequality is either less than, greater than, less than or equal to, greater than or equal to, and some might argue does not equal. So what we have is, in our first example, 6x minus 24 is less than 6. So the process you can treat kind of like the inequality as an equal symbol. We add 24 to both sides. So we have 6x is less than 30, and then we have divide both sides by 6, and we get x is less than 5. So this is where the graph is a little bit different. We put a circle at our value, and then we have to capture all the values less than that. And since it's less than 5, we have an open circle, whereas on the next problem we'll have a closed circle. So in the next problem, same scenario, we have variables on both sides of the equation. And in the first step, I subtracted 18x to one side, or to both sides. Then I added 5 to both sides. And I have this negative 2x is greater than or equal to 8. And I divided both sides by negative 2. And we need to remember, if you multiply or divide a negative number across an inequality, we need to flip the direction of the inequality. So our answer is less than or equal to negative 4, so we put a solid dot because it contains 4, negative 4, and then we shade less than, or we draw an arrow to the left of negative 4. Next page it gets just a little bit harder because we're going to use 2 variables. Alright, in the linear equations and inequalities with 2 variables, this is the sort of solution process where what you're doing is you are writing the equation in a form that makes it easiest to graph. And most people consider the slope-intercept form one of the easiest methods to graph. So that means solve your equation for y. So I wrote my equation, and then I subtract 2x from both sides, and then I divided both sides by 4. When it came to graphing that equation, the first thing I did was I plotted the y-intercept of 2, which is right there, and then a slope of negative 1/2 means down 1 over 2 units. Down 1 over 2 units, and we can draw the line that connects those two. For my graphs, I find it very important to call out the y-intercept and the x-intercept. So I've called that out on the graph to the left. The second problem, I was graphing a inequality, and for this purpose, the inequality was already written in y equals format, or more specifically, y is less than or equal to format. And so to graph that equation, the first thing I did was I plotted the y-intercept, which was 1, and then I had a slope of 3, which means rise 3 units, go over 1, rise 3 units, go over 1, and we connect those dots. Because it contains the equality, we have a solid line, and we want to shade less than, so anywhere where y is less than that line. So we're going to shade all of these spots underneath the line. And the final problem is another linear inequality, and what we have is an equation that's not yet in y equals format. So the first step I took was I subtracted 2x from both sides, and then I divided by -3, keeping in mind that if you divide by a negative, the direction of the inequality needs to flip. And I got 2/3 x plus 2. So to graph that equation, I have my axis, I count up 2 units, and then my slope is 2/3, which means up 2 over 3 units, and I have the line. But because the equation is less than, we need to actually erase some of the line and make it so that what we have is a dashed line. So we have a dashed line rather than a solid line, and we are shading above the line. Right. On the last page, I'm going to show you two systems, or sorry, a system with 2 equations.
What's his name? Quingrios.
Right, so what I've got here is a system of linear inequalities. And later on in the year, we're going to address systems of equations and inequalities, but this is so closely connected, I just wanted to go ahead and give you a preview of it now. What we want to do is graph each of our lines. So the first one that we graph is y is greater than 2x minus 3. So I count down to 3 units, and I have a slope of 2. So what we have is a diagonal line, and we are shading above the line. The second equation is y is less than or equal to x plus 5. So we count up 5 units, 1, 2, 3, 4, 5, and our slope is -1. So to the right 1, down 1. And because it's less than or equal to, we get a solid line, and we're going to shade below the solid line. And the location where we have both of them being true is right here. So at the black area of the graph, both systems, or both the inequalities in the system, are true. So that would be our solution set. Alright, this concludes the video for skill number 5. I can solve and graph linear equations and inequalities in 1 and 2 variables. And the map featured below, if you look closely up in the upper left-hand side, there was the clue of Central Park. So this is the city of New York, and this is a map of the subway lines. Down here in the lower right is Brooklyn.